Hello, in this one I'm going to show you how to find the antiderivative of 1 over x squared plus 4x plus 10 dx. So I'm going to first observe that in the bottom I have a trinomial, and what I want to do is complete the square so that I can use substitution, and also then apply the inverse tangent rule for integrands, and integrals rather. So let's carry that out, okay? So what I'm going to do is I'm going to take, at step number 2, x squared plus 4x plus 10, and I'm going to complete the square. I'm going to show you how I complete the square. That's not to say there are not other ways of doing it, of course. So I'm going to take x squared and I'm going to put just x in this position and a parenthesis next to it. That's my step 1 here. Then after that, I take the coefficient of 4x and I multiply by 1/2 above my head. So it's 1/2 of 4 at step 2 within the process of completing the square. That puts a 2 in this position, and notice this is plus 2 because it was 1/2 of 4, which is positive 2. Then of course at step 3, if you like, within the completing the square process, I have 2 squared, which is 4, and that gets subtracted in this position right here. So that's -4. And then I'm going to add the 10 to it in this position here. That's just carrying the 10 down from step 2 into this last position. So now what I have to do is clean things up a little bit. So I'm going to do -4 plus 10, which will give me a 6 as the constant term is step 4. And then here I have x plus 2 in that quantity squared at step 4. So step 4 represents the denominator rewritten after completing the square has been done. Step 5, I'm going to make replacements. There's going to be x plus 2 squared plus 6, and I'm replacing. If you like, at step 5, if you FOILed out and you added the 6, you would convince yourself immediately that that is the accurate representation of the denominator. After FOILing and combining like terms, it will take you back from 5 back to 1. That's how I know it's correct. So now I look at this bottom here and I observe some key pieces of information that are critical. So first of all, I notice I have a quantity with a variable and it's squared. I notice I have a plus here. I notice I have only 2 terms in the denominator, and I have a 6 in this position. So it's kind of hinting that perhaps the inverse tangent function will be the right kind of approach here. You got to make those preliminary observations. But let's take it to the next step. So the inverse tangent function, usually the way it's given is that it's like 1 over, for example, x squared plus a squared. Now this is an x plus 2 squared. So not just like a variable, but a variable expression, an x with a 2. So for that reason, it's telling me I can try to make step 5 into something that is more directly doable using the inverse tan through u substitution. And I proceed as follows for that reason. At step 6, I'm going to do u equals x plus 2. So when I differentiate, that's going to tell me that du equals dx because the derivative of x is 1, the derivative of 2 is 0. In other words, you just end up with du equals dx at step 7. Let's go up here to step 8. So in step 8, what am I doing here? X plus 2 has been replaced with u directly from step 6. Again, from step 7 down below, if you look carefully, you see that du equals dx. Therefore, dx can be replaced with du exactly. I'm converting everything to u's. And I still have that 6. So at step 8, I have a 6, but the inverse tangent rule for integrals says you have to have something squared in that position, not like a 6. So at step 9, we apply a common trick, which is that I'm going to rewrite this whole number 6 at step 8, at step 9 as the square root of 6 squared. And I can do that. I can do that because the 2 would kill off the square root and it would take you back to the constant 6 in step 8. But at step 9, I need to have it in this form so that I can apply the inverse tangent rule for integrals. That's it. So I do that the next step when I transition to step 10. That tells me the following, that I'm going to have 1 over the square root of 6. That's what the inverse tangent rule for integrals tells us. It's 1 over a. In this case, a is the square root of 6. So that goes over here. 1 over a becomes 1 over the square root of 6. Then you apply tan inverse. And again, after that over here, that basic inverse tangent rule says that it's x over a. But in our case, this is u playing the role of x, so I put it over here, it's u. And then a is played by the square root of 6, so that goes here as the square root of 6 under the u. And the c is attached as a constant of integration. But remember that u was defined originally to be x plus 2. Therefore, at step 12, I keep my 1 over the square root of 6, doesn't change. I keep my tan inverse, doesn't change. But the u you saw at step 10 is replaced with x plus 2 over the square root of 6, and you keep that constant c added at the very end the whole time. And that is about it for this one. So thank you so much for watching. Please leave a like and subscribe. I appreciate the fact that you have spent some time with me. I hope this has been genuinely helpful. I'll see you in another video.